ओके बेटा, तो इलेक्ट्रोकेमिस्ट्री के ऑब्जेक्टिव क्वेश्चंस हम कर रहे हैं। लेवल 1 किए थे हमने लास्ट 2 लेक्चर से, और अब ये लेवल 2 के क्वेश्चंस है। तो फर्स्ट क्वेश्चन है द स्ट्रॉन्ग इलेक्ट्रोलाइट अमंग द फॉलोइंग CCl4, CH3COH, KCl एंड NaOH। तो ये चार में से द करेक्ट कॉम्बिनेशन इज, tell me which one is the correct combination? Yes beta, which one is the correct combination? Hello? तो फर्स्ट ऑप्शन जो है that cannot be there because CCl4 cannot be acting as an electrolyte. It is neither strong electrolyte nor weak electrolyte, though it is not an electrolyte, because electrolyte means which gives ions in the solution, in aqueous solution. Acetic acid, it is an electrolyte, but it dissociates feebly, so it is a weak electrolyte. So this is also not the correct option. So KCl and NaOH, you know KCl is a salt. Salts are always strong electrolytes. And sodium hydroxide, it is a strong base, so it is also a strong electrolyte. That means 3 and 4 is the right option. Strong acid, strong bases, and salts of strong acid, strong base, salts of weak acid, strong base, salts of strong acid and weak base are strong electrolytes because they undergo nearly complete dissociations in solution. So both 3 and 4 is the correct option. Got beta? Got it? Second is, in order to get 9 gram of aluminium, the atomic mass is 27. During the electrolysis experiment, how many Faraday of electricity has to be passed? How many Faraday of electricity has to be passed? Options are 3 Faraday, 2 Faraday, 1 Faraday or 1.5 Faraday. Yes beta. Okay, see 9 gram of aluminium during electrolysis. So you know aluminium is actually 3 plus, it will gain 3 electrons to give aluminium. So 3 Faraday will deposit 27 gram. So 9 gram is deposited by 1 Faraday, and that is the equivalent weight of aluminium. Oh, कल से शुरू कर देंगे, ठीक है? So 1 Faraday deposits 1 gram equivalent of aluminium, so 9 grams. So 1 Faraday is the right option. Okay, how much copper can be deposited by 2.5 Faraday of electricity? So first is 2 moles, 2.5 moles, 1.5 moles, or 0.125 moles. Yes, beta. How much copper can be deposited by 2.5 Faraday of electricity? So you know copper, in most of the cases it is 2 plus in aqueous solution, so it will gain 2 electrons. So 2 Faraday of electricity will deposit 1 mole of copper. So 2.5 Faraday of electricity will deposit 1 into 2.5 over 2. That means 1.25. So 1 Faraday deposits 1 gram equivalent of copper. And what is 1 gram equivalent? That is gram molecular weight over valency. So half mole. So valency of copper is actually 2. 2.5 Faradays deposits 1.525 mole. Next question. 1 Faraday of electricity will liberate 1 gram atom of the metal from the solution of, yes beta, 1 Faraday of electricity will liberate 1 gram atom of metal from the solution of, yes beta, 1 gram atom means 1 mole, because there is a difference between 1 gram of atom or 1 gram atom. 1 gram of atom means 1 mass is 1 gram, or 1 gram atom means 1 mole. So 1 Faraday of electricity will liberate 1 gram atom of metal from which solution? So if we talk about first case, in this case 2 Faraday will deposit 1 gram atom. First and second. In third case, Ag plus will gain 1 electron. So 1 Faraday will deposit 1 mole, 1 gram atom. In AuCl3, Au3 plus. So that will 3 Faraday will deposit 1 gram atom. So that means which option is true? That is third. So see, 1 Faraday deposits 1 mole of silver, half mole of copper, half mole of copper from copper sulfate, 1/3 mole of gold from AuCl3. So 1 Faraday anode, cathode, 1 coulomb is a reduction, 96,500 coulombs, 6.24 into 10 power 18 electrons, oxidation Z into 96,500. So which option is true? Which option is correct? So see, 1 Faraday. So tell me, 1 Faraday is equivalent to, yes, so 1A has second option. So A has second option in B and C. So A and D options we can neglect, we can reject. Next is anode. So at anode, yes, at anode oxidation takes place. That means B should have 4 options. So it has 4 in both the cases. Cathode is reduction, that is true in both the cases. Now 1 coulomb. So 1 coulomb is equal to, you have option number 3 and 5. Yes, beta. So 1 coulomb is equal to what? That I don't know. 1 coulomb is equivalent to electrons. Sorry. 1 Faraday's charge of 1 mole of electrons. So, and at anode oxidation takes place, at cathode reduction takes place, and you know 96,500 coulomb charge that contains 6.023 into 10 power 23 electrons. So 1 coulomb contains 6.24 into 10 power 18 electrons. Good. So that means option B is correct. Good. Okay, so these are the list 1 and list 2. 1 Faraday of electricity through aqueous solution of silver nitrate. 1 Faraday of electricity through aqueous solution of copper sulfate. 1 Faraday of electricity through the molten solution of AlCl3. 1 Faraday of electricity through molten NaCl. So see the reactions. In AgNO3, Ag plus will gain 1 electron. In copper sulfate, copper 2 plus will gain 2 electrons. AlCl3, Al3 plus will gain 3 electrons. And NaCl, Na plus will gain 1 electron. So see, 1 Faraday will deposit 1 mole of silver. 1 Faraday will deposit half mole of copper. 1 Faraday will deposit 1/3 mole of aluminium, and 1 Faraday of electricity 1 mole of sodium. So 1 mole of sodium is equivalent to 23 gram. 1 Faraday of silver nitrate, silver atomic weight of silver is 108. Half mole of copper is equivalent to 31.75, and 1 Faraday of electricity through molten NaCl3 means 1/3 mole is equivalent to 9 gram. That means it should be A3, B is 1, C 4, and D 2. So this is the right option. See, 1 Faraday of electricity through aqueous solution of silver nitrate, 1 gram equivalent. That I have already explained you. That is key. A current of 3 ampere was passed through the solution of AuCl for 1 negative ions using gold electrodes, and it caused deposition of 1.234 gram of gold. The time for which the current was passed is, atomic mass of gold is given to you. Now see, we have current, that is 3 ampere, and weight of gold 1.234 gram. Time we have to calculate. And you know, in AuCl4 negative, what is the charge on the gold? It is +3, means Au 3 plus will gain 3 electrons to give Au, right? So its equivalent weight is 197/3. Okay, so just apply the Faraday's first law, that is Z into I into T, that is equivalent weight into I into T, or equivalent weight divided by 96,500. That's it. So see, valency of gold is 3, weight weight of gold 1.234, equivalent weight is 197/3, current is 3 ampere, 96500, and time. So you have to calculate time. Time is 604.5 seconds. That's it. Next question. 2.5 Faradays of electricity is passed through a solution of copper sulfate. The number of gram equivalents of copper deposited on the cathode would be. Yes, madam. 2.5 number of gram equivalents. It is not number of moles. Number of gram equivalents. You know, 1 Faraday deposits 1 gram equivalent. If it is number of moles, then you are right. But 2.5 Faraday deposits 2.5 gram equivalents. See, it is number of gram equivalents. If it is written as number of moles, then you are right. Got it, beta? Because 1 gram equivalent is half mole. See, copper 2 plus 2 electron. It will gain 2 Faraday will deposit 1 mole. But 1 Faraday will deposit half mole, and that is equal to 1 gram equivalent. Got my point? Next is at STP, 1.12 liter of hydrogen is obtained on flowing a current for 965 seconds in a solution. The value of current is, see, time is given. 1.12 liter of hydrogen gas is obtained on flowing a current of this at STP in a solution. So we have to calculate the value of the current. So you know, this is the reaction. Okay. So 2 Faraday of electricity, if it is passed, we get 1 mole of hydrogen gas at STP. And 1 mole of hydrogen gas means 22.4 liter at STP. So that need 2 Faraday of electricity. So 11.2 liter will require 1 Faraday. So 1.12 liter will require 0.1 Faraday of electricity. And you know 0.1 Faraday means 0.1 into 96,500 coulomb. And that is equal to I into T. I is given to you. No, I you have to calculate. And time is 965 seconds. So 965 is 100. That means comes out to be 10. The weight of hydrogen is number of moles of hydrogen into is comes out to be 10 ampere. You can go like this or you can go like this, because you know it 1.12 liter of hydrogen, and that is equivalent to how much that you have to find out first in terms of grams. In terms of volume, you can go like this. How long will it take to remove half of silver from 200 centimeter cube of 0.1 molar silver nitrate solution with a current of 0.1 ampere? Means you have to calculate the time. Yes, madam. कैसे फाइंड आउट करोगे बोलो? So you have 200 ml of 0.1 molar. So you can calculate number of millimoles from here. So millimoles is 200 into 0.1 means 20 millimoles with a current of 0.1 ampere. That is silver nitrate. So Ag plus, gain 1 electron to give silver. So 1 Faraday will deposit 1 mole, right? So 1 millifarad means 10 to the minus 3 Faraday will, what is the answer? Okay. So weight of silver is equal to moles into gram atomic weight of silver. So moles is 200 divided by 1000 means number of moles is molarity into volume in liter. So it is volume in ml. So 200 over 1000 into 0.1 and atomic weight is 108. So in this way we will get the atomic weight of silver deposited, that is half of the 2 into 1.08. Okay, so that is the weight of half into 2 into 1.08 and weight is ACT means current into time into equivalent weight, atomic weight over valency. Time comes out to be 160.83. Okay, great. कैसे किया आपने? It's okay, that's not the issue. तो यहाँ पे number of millimoles कितने थे? 20, right? ओके, सो यहाँ पे जो 1 Faraday है that will give 1 mole. Okay, so we for 1 millimole we need 1 millifarad. So 20 millimoles of silver to deposit we need 20 millifarad. So 20 millifarad means equivalent to 20 into 10 raised to power minus 3 Faraday. This much electricity is required in terms of Faraday. Okay, so here it is 0.1 ampere, current is 0.1 ampere. So 0.1 into time in seconds, ampere second is coulomb, so into 96500, it is equal to 20 into 10 raised to power minus 3 into 96500 divided by 0.1. So it is 20 into 0.1, you can remove is 0, so 965. मेरा तो गलत आया फिर. अच्छा, it is in minutes, right? So it is in second, so 20 into 9 divided by 60, so 3 965 over 3 seconds. वो भी अलग आया, कहाँ पे गलती हुई? 20. अच्छा, how long will take to remove half of the silver? See, How long will it take to remove half of the silver from this? And we are calculating. Yes, half of the silver. Okay. तो यहाँ भी कर सकते हैं, जो टाइम आया ठीक है उसका हाफ कर दिया. हाफ मीन्स डिवाइड बाय 3 है ना, तो इसको 965 डिवाइड बाय 6 कर दिया तो भी आ जाएगा. ओके. अभी तो इसने यहाँ किया ना, वेट ऑफ सिल्वर टू डिपॉजिट इज हाफ ऑफ द वेट. वी हैव टू half it. Okay. Next is how many centimeter cube of O2 at STP will be liberated from acidified water by 193 coulomb of electricity. How many centimeter cube of O2 at STP will be liberated from 193 coulomb of electricity from the acidified water? So you know 96500 coulombs liberate means 1 Faraday, that will liberate 1 gram equivalent of oxygen. 1 gram equivalent of oxygen means 16 by 2 means 8 gram of oxygen. So 8 by 32 moles of oxygen, that is 8 by 32 into 22.4 liter of oxygen, that is 5.6 liter of oxygen, or 5.6 into 1000 centimeter cube. So 193 coulomb deposits 96500 coulombs will deposit 5.6 into 10 raised per 3 means 5.6 into 1000 centimeter cube. So 193 coulombs deposits 11.2 centimeter cube. Next is the charges required for reduction of 1 mole of Cr2O7 negative ions to Cr3 plus ion is. Yes, beta. So see, we have Cr2O7 negative. So Cr2O7 negative will gain or will have to have 6 electrons to get Cr3 plus. The charge of 1 mole of electron is 196,500 coulombs. The charge of 6 mole of electron is 6 into 96500 coulomb. So it is like this. You have to just see it is plus 6 to plus 3. So change is of 3, but there are 2 chromium in one Cr dichromate. So 6 mole or 6 Faraday of electricity. What is the electrochemical equivalent of silver? Yes, beta. Electrochemical equivalent of silver. What is the electrochemical equivalent in gram per coulomb of silver? So, 1 Faraday deposits 1 gram equivalent of weight, that is 108 gram. So 1 coulomb current deposits 108 gram of silver divided by 96500. So it is 108 by F. Very good. 0.5 Faraday of electricity was passed to deposit all the copper present in 500 ml of copper sulfate solution. The molarity of the solution is, yes, beta, 0.5 Faraday of electricity that was passed to deposit all the copper present in 500 ml of copper sulfate solution. So what is the molarity of the solution? So see, how do we proceed? You know, 1 Faraday of electricity is equivalent to 31.75 gram of copper, because in copper sulfate, copper 2 plus 2 electron to give copper. So what is equivalent weight of copper? 63.5 divided by 2. Okay, so it is 31.75 gram. So 0.5 Faraday will deposit 15.875 gram. 15.875 divided by 63.5 into 1000 over 500. So it is 0.5 molar. An ion is reduced to the element when it absorbs 6.6 into 10 raised to power 20 electrons. So number of equivalents of the ion is, yes, an ion is reduced to the element when it absorbs this much electrons. So number of equivalents of the ion is, very good. Okay, one normal is one equivalent weight. So 6 into 10 power 20 into 1 is equal to divided by 6 into 10 power 23, 0.001. Very good. In which one of the following 1 Faraday of electricity liberates half gram atom of the metal? 1 Faraday will deposit half gram atom of the metal. Yes, madam. Which option is correct? One Faraday of electricity liberates half Faraday, half gram atom of the metal. Half gram atom, you know, half gram atom means half mole. Just see the charges. It is Au3 plus, Fa3 plus. Yes, it is. Yes, because 1 Faraday of electricity liberates 1 by 3 gram atom of gold, because it is 3 plus. It is again 1 by 3 gram atom, half gram atom, and 1 gram atom of sodium. So it is copper sulfate. Number of electrons involved in the reaction when 1 Faraday electricity is passed through an electrolyte. One Faraday of electricity is passed through the electrolyte. The number of electrons involved in the reaction, obviously 1 mole, because 1 Faraday is the charge of 1 mole of electrons. This much electrons should pass. Okay, when electricity is passed through molten AlCl3, 13.5 gram of aluminium is deposited. So the number of Faradays must be, Al3 plus 3 electron to give aluminium. 13.5. It is 27, means it is half mole of aluminium. Tell me how many Faradays are passed? 1 Faraday deposits 1 gram atom of aluminium 3 plus. That is 9 gram. So 9 gram of atom that was deposited by 1 Faraday. So 13.5 grams of aluminium deposited by 1.5 Faraday. Or you can go like this, that 3 Faraday will deposit 27 gram. So 1.5 Faraday will deposit 13.5 gram. It is up to you. Yes, beta. Second last question. 3 Faradays of electricity is passed through molten Al2O3, aqueous solution of copper sulfate, molten NaCl, taken in 3 different electrolytic cells. The amounts of aluminium, copper and sodium deposited at the electrodes will be. Yes, beta. Aluminium is 3 plus in Al2O3, copper is 2 plus in copper sulfate, sodium is 1 plus in NaCl. It is taken in 3 different electrolytic cells. So the amounts of aluminium, copper and sodium deposited at the electrodes will be, and 3 Faradays of electricity is passed. When you pass 3 Faraday of electricity through aluminium 3 plus, how much aluminium is deposited? 1 mole. And through Na plus, if 3 Faradays passed, you will get 3 moles. 1 mole and 3 mole. And what about this? If you pass 2 Faraday of electricity, you will get 1 mole. And 1 Faraday will give half mole. You can go like this. See, 1 Faraday, 1 by 3 mole. 1 Faraday, half mole. 1 Faraday, 1 mole. In 1, 2, 3. So, 3 Faraday, 3 by 3, 1 mole. 3 by 2, 1.5. 3 into 1. So, it is option number 2. 1 Faraday of electricity deposits 1 gram atom of each metal. Into 1 by 3 gram atom of aluminium. It is gram equivalent. By mistake, it is written as gram atom. It is gram equivalent. So 1 by 3 gram gram equivalent. 1 by 3 gram atom, okay, but here half gram atom of copper, 1 gram atom of sodium. So it is option number 2. Last question. The ratio of the weights of silver and aluminium deposited at the cathodes respectively when the same current is passed for the same period of time through molten Al2SO4 thrice and aqueous AgNO3. Yes, beta. Same current, same time, means these cells are connected in series. One is silver, other is aluminium. Ratio of the weights of silver and aluminium. You can see silver will gain 1 electron, then aluminium will gain 3 electrons. Same current is passed for the same period. Tell me, 1 Faraday will give 1 mole, 3 Faraday will give 1 mole. 12 is to 1. According to Faraday's second law, weight of aluminium to weight of silver deposited is equivalent weight of aluminium to equivalent weight of silver. So very good. 27 by 3, 108. So it is okay. It is written as aluminium to silver. So it is silver to aluminium. So it is 12 is to 1, because equivalent weight of silver to equivalent weight of aluminium, that is equal to weight of silver to weight of aluminium. It is 108 by 9, right? Okay, that's it. So we will stop here. Okay. But the next class say we will start the chemical kinetics. Okay. Okay, but do like the video. I hope कि ये आपको पसंद आया होगा. So please share the video with your friends and do like the video please. That will boost my morale और मैं उस तरह से काम करने के लिए रेडी रहूं आपके लिए. For that, do like the video. Thank you so much to all of you. Have a great day. Happy learning.